Welcome to Mathematics Online Lecture Series, lecture number 17. Change of order of integration in double integrals by Professor Kevin Narsum, Department of Mathematics, London Institute of Engineering Technology. Problem number 8. Today we will discuss another problem using change of order of integration for evaluation of double integral. Evaluate the integral by changing the order of integration. Double integral of integral 0 to a integral square root of ax to a y square by square root of y power 4 minus a square x square dy dx. If we observe this integral, the first integral is this one, second integral is this one. Now first integral is first one, this is second. In the first integral, the variable limits in terms of x, so this is y limits. Y varies from root over ax to a and other variable is x. Here only two variables. Y limits root over ax to a and x limits 0 to a. So which is clearly written here. Given that x is 0 to a, y is square root of ax to a, y square by square root of y power 4 minus a square x square dy dx. Now we will evaluate this integral using change of order of integration. So usually we will integrate with respect to y, then integrate with respect to x. In change of order of integration, change the order of the variables. First we will integrate with respect to x instead of y. Then we will integrate with respect to x. Now for this purpose, in this method, first identify the region. First step is identify the region. Then change of order of integration, COI, change of order of integration, then evaluation. For this purpose, first we will identify the region of integration. Region of integration, y equals to square root of ax to y equals to a and x equals to 0 and x equals to a. So squaring on both sides, this term squaring on both sides, y square equals to ax, it represents a parabola. Now what is the shape of the curve? So y equals to root over ax is nothing but a parabola. So which is look like this one. This is y square equals to ax. Now another one is y equals to a. Y equals to a is a straight line parallel to x-axis. So here clearly mentioned this is y equals to a and this is y square equals to 4ax. If y square equals to ax. Now, and also if you find the point of intersection of these two curves, suppose if you put y equals to a in this equation, then what happened? A square equals to ax. Then x equals to a can x equals to a and y equals to a. Now this is the point of intersection of this line, straight line and parabola. Now this is a point A. Now parabola passing through origin, we know this one. Now this is nothing but y equals to b. Now what is the region between, now what is the integral y equals to root of ax means observe along y-axis. Lower curve is parabola, upper curve is y equals to x. And x is 0 to, x coordinate is 0 to x coordinate a. So this red color region is our region. So we are identified the region for this double integral. Now we will change the order of integration. Now change the x variable and y variable, then what about the limits? So what is our method? Integrate with respect to x, then integrate with respect to y. So for finding the limits of x, now observe along x-axis. Along x-axis, I will take another color. Along x-axis, if you draw a line along x-axis in this region, so first one is this one, x equals to 0. X equals to 0 to this curve. This curve is nothing but from this one, x equals to y square by a. So x limits 0 to y square by a. Now y limits. Y limits here x equals to 0. So maximum value is a. Here y equals to 0 to a. Now by change of order of integration, the limits are x is 0 to y square by a, clearly mentioned, y equals to 0 to a. Now, using these limits, we will evaluate the integral. By change of order of integration, here actually we will integrate with respect to y, then integrate by using change of order of integration, first with respect to x, then with respect to y. Now, x limit 0 to y square by a and y limit 0 to a, already mentioned. So now in this integral, first we will integrate with respect to x, then integrate with respect to y. Now, for integrating with respect to x, separate the x variables and y variables inside x variables, outside y variables. Here x variables, here y square is constant, so place outside the box. Here, in these two terms, okay, square root of a square minus x square. Now, if you common a square under the root, you will get a in the denominator. That is 1 by a. 1 by a. Integral 0 to y square by a. Now same. Now y square is outside 1 by square root of. If you common a square, now this become y square by a whole square. Actually y power 4 by a square if you common. Now whole square form y square by a whole square minus x square. This is look like integral 1 by square root of a square minus x square dx. This is look like this integral. What is the integral formula? Sine inverse x by a. Sine inverse x by a. Now, if you observe, this is 1 by a, same 1 by a, integral 0 to a, integral 0 to a. Here, now this term is entirely, this y square by a is constant, y square by a is constant, x square. Now, what is the formula? X by a. X by constant term is y square by a. Limits integral 0 to y square by a, y square dy. Now substitute the limits. First put x equals to, in terms of x, put x equals to y square by a, then 0. If you put x equals to 0, sine inverse 0 is 0. This is sine inverse 0. Sine inverse 0 is already 0. Now y square by a, both are cancelled. Sine inverse 1. Sine inverse 1 is pi by 2. Already known. So if you common pi by 2 a times of integral 0 to a. Now this is entirely constant y square dy. Integral y square is known formula. Y square is integral y square dy equals to y cube by 3. Y cube by 3. Now y cube by 3. Now they observe this one, y cube by 3. Pi square by 2a, y cube by 3, limit 0 to a. First put y equals to a, then y equals to 0, 0. So if you put y equals to a cube, pi by 2a into a cube by 3 minus 0, so not required. Here a square, a and a cancel, pi a square by 6. Finally, you will get integral 0 to a, y into root of ax by y square by square root of y power 4 minus ax square, a square x square dy dx equals to pi a square by 6. Now this is very simple and most important question. So we will discuss the remaining problems in the next lecture, which are most important. So splitting into the two regions, that one is most important concept in change of order of integration. Here Directly we are evaluating the integral. Suppose if the given integral is given, then find out the region, then find out the change of order of integration, then integrating. In the next problems, the total region may divide into 2 or 3 parts. So depending on the splitting, then we will separate the integrals. We will discuss in the next lecture, which is most important concept in change of order of integration. If you have any doubts, ask me through my email ID or WhatsApp number. Thank you. Thank you very much. Meet again.